Hi, good day. Welcome to Precalculus series. In this video, I'm going to discuss angles and angular measures. Now, let us have the definition of an angle. From the definition, an angle AOB is a plane figure consisting of two rays, namely r sub 1 and r sub 2, having the same endpoint O. The ray r sub 1 is called the initial side. The ray r sub 2 is called the terminal side, while the common endpoint O is called the vertex. Now, to simplify the definition, we can say that an angle is the union of two rays having a common endpoint. And these rays are the initial side and the terminal side respectively. And their common point is what we call the vertex. The figure below shows an illustration of an angle. In this lesson, we assume that the initial side is aligned horizontally. Angles can be represented symbolically using the following Greek alphabets, like theta, and other Greek alphabets like alpha, beta, gamma, omega, lambda, and so on and so forth. Suppose this point represents the vertex of an angle. Now, if we rotate the initial side, so suppose that this one is the initial side of an angle. So if we rotate the initial side of an angle in either clockwise or counterclockwise direction, the position wherein the initial side stops is the terminal side of an angle. So in this case, this one is what we call the terminal side of an angle. And we can represent the gap between the initial and the terminal side using, let's say, theta. An angle can be classified according to its rotation. We have the positive and negative angles. From the definition, an angle is said to be positive if the direction of the rotation is counterclockwise. And on the other hand, it is said to be negative if the direction of the rotation is counterclockwise. The first illustration shows a positive angle. That is, the initial side rotates in a counterclockwise direction. Let's say I name this as an angle alpha. The second figure shows an example of a negative angle. That is, the initial side rotates in a clockwise direction. Let's say I name this as an angle beta. Consider the initial side of an angle as shown on the screen. If we rotate the initial side until it coincides with itself, we say that an angle forms a complete revolution. An angle forms a complete revolution by rotating the initial side counterclockwise exactly once until it coincides with itself. So the figure below shows an example of an angle that forms a complete revolution. The measure of an angle, or the angular measure, is the amount of rotation from the initial side to the terminal side. There are two approaches used in quantifying angle measurement. These are the degree measures and the radian measures. Later, we are going to differentiate them. The first way of measuring angles is in terms of degree measures. The angular measure in degrees is denoted by the symbol. A measure of 1 degree is the measure of an angle formed by rotating the initial side 1 over 360th of a complete revolution about the vertex. The figure below shows the measure of an angle in terms of degrees. Imagine that we cut an angle that forms a complete revolution into 360 equal parts. Each part corresponds to 1 degree. Let us have this illustration. Now, illustration number 1. Suppose that we have the 45 parts out of 360 parts. Now, this amount of rotation of an angle represents an angle measure of 45 degrees. Illustration number 2. Suppose that we have 90 out of 360 of a complete revolution. This rotation corresponds to 90 degrees. Last illustration, let's say we have 270 over 360. So this amount of rotation corresponds to 270 in terms of degrees. The second way of measuring an angle is in terms of radians. Let us have a definition. Given a unit circle that is drawn with the vertex of an angle at its center. From our previous lesson, we know that a unit circle is a circle whose radius r is equal to 1 unit. Now, the measure of the central angle in radians, that is abbreviated as RAD or rad, is the length of the arc that subtends the angle. So from the illustration below, the length of the arc that subtends the central angle theta is what we call the measure of an angle in terms of radian measures. Now, please consider the following examples. Consider illustration number 1. Since the length of the arc is 1 unit, therefore, we can quantify an angle theta in this example as theta is equal to 1 radians or 1 radian. Or to simplify further, we can say that theta is equal to 1 rad. Let us have example number 4. Take a look at the length of the arc that subtends the central angle theta. Now you can see that the length of the arc measures 2 units. So from the definition, we can say that the measure of an angle theta is equal to 2 radians. Or to simplify, we can have theta is equal to 2 rad. Before we answer items 2 and 3 from the illustration, let us have this another illustration. Let's say we have an angle, a central angle theta, that is inside the unit circle. Now suppose that an angle forms a complete revolution, and the said angle theta lies on the unit circle. Now my question is, how can we measure the length of the arc from the initial side up to the terminal side, wherein the initial side and the terminal side coincides? If we measure the length of an arc wherein the initial side coincides with itself, let us recall a formula from geometry. So remember the term circumference. Let us have a recall. Circumference of the circle circumference is the length of the circle. Now, in order for us to measure the length of the circle or the circumference, we apply the formula circumference is equal to 2 pi r. The r from the formula corresponds to the measure of the radius. Now, from the given illustration, since r is equal to 1, by substitution, we can have 2 pi times 1, simplifying their product, so we have 2 pi. So based on this computation, if we compute for the circumference of the circle, where r is equal to 1, the length of the circle is said to be 2 pi units. So therefore, we can quantify the length of this arc wherein the initial side coincide with itself as 2 pi units. So if we wish to measure the measure of an angle or central angle in terms of radians, wherein the initial side coincide with itself, since the length of the arc measures 2 pi units, therefore, we can say that pi, or theta rather, is equal to 2 pi radians. Or simply, theta is equal to 2 pi rad. So notice from this example that the central angle theta forms a complete revolution. That is, a complete revolution is equal to 2 pi in terms of radians. Now, let us have illustrations 2 and 3. From illustration number 2, you can notice that the length of the arc is half of 2 pi units. That is, we have pi units. So therefore, to measure the central angle theta, since the length of the arc is pi units, therefore we can say that theta is equal to pi radians. Or simply, theta is equal to pi rad. And then lastly, in number 3, you can see that the length of the arc is pi over 2 units. Since the length of the arc is pi over 2 units, therefore, the measure of the central angle theta is equal to pi over 2 radians, or simply pi over 2 rad. That's how we measure an angle in terms of radians. So remember that to quantify an angle in terms of radians, you have to quantify the length of the arc that subtends the central angle theta. To summarize, when we measure an angle in terms of degrees, we count the number of 1 over 368 of a complete revolution. On the other hand, when we measure an angle in terms of radians, we measure the length of an arc of a unit circle that subtends the central angle theta. From the two methods of measuring an angle, the following identities can be observed. So take note that a complete revolution is equal to 360 in terms of degrees and 2 pi in terms of radians. So their half, or 1/2 revolution, is equal to 180 in terms of degrees, and a half of a complete revolution is also equal to pi in terms of radians.